Hi, this is Miloslav Čapek from CTU in Prague. Today I would like to present you some remarkable features of AToM, which is the abbreviation of Antenna Toolbox for Matlab. AToM is a standalone Matlab toolbox which can be easily started by writing the following command into the command line. By default, it is started with graphical interface, but it can be started also without it, like in this case. For example, to process some prepared batch files. The variable AToM at the left side is a reference to singleton AToM object. AToM consists of more than 200,000 of Matlab code lines. Therefore, to show all its powerful features in one video is nearly impossible. However, let's start with the most important features and let's show them mainly from graphical user interface. In AToM, you can create your own projects or open previously created ones. You can have many projects open simultaneously, but a common practice is to work with exactly one project at a time. The philosophy of AToM is that everything you can do in graphical interface can be also done directly from Matlab command line or controlled from your scripts and functions. To be able to do that, we implemented AToM history, which records all actions in AToM, like now when we created simple rectangle and see, we got our first command in AToM. The same command can be repeated multiple times to get, for example, antenna array. Many keyboard shortcuts are predefined in main viewer and in design viewer for effective work in AToM. For example, by pressing Ctrl+A and then delete makes it possible to select all objects and delete them. The next important part of AToM is the AToM Workspace, situated here at the top right corner of my screen. You can define your own variables to fully parameterize models and settings. Generally, all edit windows in AToM with gold background color support AToM Workspace variables. AToM Workspace is, however, much more powerful as it can interact with Matlab functions and scripts. It is also capable to upload important physical constants by clicking on Load Constants. Since Design Viewer supports Boolean operations, we have freedom to design radiator we want and then proceed to meshing. AToM contains its own mesher with some unique features. For example, the size of mesh grid can be related to the frequency, or it can be determined in absolute units. The quality of mesh can be easily displayed and, if needed, the mesh grid can be automatically updated by enabling Mesh on Fly option. You can see that our mesher is extremely fast and produces mesh of high quality. Sometimes we want non-homogeneous mesh density, for example, to mimic the Maxwell distribution of current along a dipole. This can be easily done in this window. Now we have a nice dipole, so why not to calculate something? And let's take a look at characteristic modes. First, we set up our list of frequencies, where we utilize uploaded constants and a length of dipole represented by variable L from AToM Workspace. We click on OK and move to the solver options. In Generalize Eigenvalue problem, we select MOM2D, which is the conventional characteristic mode decomposition, and then we start the calculation. The model solver has many options and possibilities. We will introduce them later in the problem-dependent examples. The characteristic mode solver is powered by the method of moment kernel, which supports symmetry planes, lumped elements, junctions, and other standard features. The results are already calculated here, represented by eigenangles or eigenvalues, and we can inspect them in details in the Results tool. To do so, we click on Results in the main viewer and upload the data by clicking on Load GEP data. You can see that many antenna parameters can automatically be calculated, and there will be even more parameters while we calculate not only the model decomposition, but antenna fed by, for example, delta gap. As a final picture, I would like to show you the characteristic currents on a dipole. To conclude this video, notice that all operations are fully accessible from Matlab and they can be freely mixed with other code written by the user. This makes from AToM powerful and versatile package for antenna analysis, synthesis and optimization. I will try to do my best to prove this claim in the future posts devoted to design of some canonical antennas in AToM.